Yeah, my name is Mike Shewring. I'm one of the project ecologists working on the Lost Peatlands project, alongside my colleague Joey, who's going to talk about some of the aspects of monitoring this afternoon, but I'm going to cover some of the restoration stuff. So I'm going to introduce you to the restoration sites this morning. Already heard from Becky, Charles, Richard and Scott about the origins of the project and a little bit about the landscape history. I'm going to zoom in a little bit more on that, so kind of more recent landscape history and how that's fed into our works, really, how we went about designing restoration and what we actually physically did on our site, where those sites are, things like that. But kind of first of all, why are peatlands important, and why are we doing this, and why should we care? Quick recap: peat is a carbon-rich soil made up of partly decayed vegetation, essentially. That's built up through time, and the decay process is inhibited because the water table is often very high in peatlands for most of the year. And the acidic nature of the habitat as well also inhibits that breakdown. And peatlands are a really important carbon store. So the area covered by near-natural peatlands is somewhere around 3 million square kilometres globally, and it sequesters about 0.37 gigatons of carbon every year. And it stores more carbon than all the vegetation in the world combined, really. Around the globe, around 46 million hectares of peatland are degraded, it's estimated. When peatlands are degraded, they emit carbon, so they move from being this sink of carbon, storing carbon for the long term, to emitting carbon when they're in poor condition through drainage or other factors. So peatlands are a really important carbon store. But they also supply, a whole host of other ecosystem services. Charles has touched on some of them, Becky and Richard as well. So things like water flow regulation. So these peatlands can sit on top of the hills and act like a sponge, holding rainfall in and releasing it out slowly over time, and that can help with, summer flows in streams. Also help with downstream flooding, issues that we see in the valleys. But also, supplies really important wildlife habitats for unique biodiversity. And also cultural services, like Charles touched on, they're nice places to be for recreational access and, recreational activities. And also really important environmental archives, like Charles touched upon with the pollen stores. They provide really important environmental archives, allowing us to look back and see what landscapes looked like in previous times. And also can store really important human artifacts as well. And where do we find peatlands? In the UK and more globally, blanket peat, and this is the peat we're mostly talking about today, really needs an oceanic climate to form. So lots of rainfall, essentially, and generally cool summer temperatures. So it's also found in places like Ireland, lots in Ireland, on the east coast of Asia, west coast of the United States, and also in Canada. And when we zoom into the UK, the distribution in the UK is largely, western and upland areas. So you can see a map on the right there showing kind of peatland distribution in Wales. And peatland in Wales makes up somewhere between 4 or 5% of the land area. So you're looking at around about 90,000 to 120,000 hectares of peatland in Wales. And sadly, most of the peatlands in Wales are currently degraded, so one shape or form. So around about 80% are not wet and boggy. They're slightly drier. And as we talked about previously, peat soil, when it is wet, is a really good carbon store. And when it's not, when it's degraded through things like drainage or wildfire, it releases greenhouse gases. So then, the sustainable management of peatlands and the appropriate management and the restoration is really key for our delivery of net zero. So the Committee on Climate Change touched on this and recommended we should be restoring around about 50% of our upland peat by 2050 and 25% of our lowland peat if we're going to hit net zero goals. And the cost of doing that is not insignificant. It needs a lot of investment. But the payback, when you look at carbon prices, is like 5 to 10 times efficiency, really. So restoring peatlands through things like rewetting, which we're going to talk in a minute, is really a relatively inexpensive way of delivering multiple benefits, all those ecosystem services, as well as the carbon benefits and biodiversity. So we've seen this slide a couple of times already, really, and this is just the broad project area where we sit, north of the old county of Glamorgan, the Alps of Glamorgan, as Richard mentioned, this kind of landscape of deeply incised valleys with an upland plateau surrounding it. And these are the specific lost peatland sites that Becky kind of talked around as well earlier on, where they're located in the landscape. So you've got, I'm going to specifically be talking about the habitat restoration areas, and these are located on the upland plateaus, sat above the deeply incised valleys, about 100, maybe 200 metres above the valley floor, on these upland plateaus that have allowed peatland development over the last maybe 4, 5, 6,000 years, something like that. So our 2019 surveys built on the information that was already held by NRW. So the baseline survey work we did in our development phase helped us identify these sites. The 3 restoration areas, so the Creggan restoration area, Cwm Cybran and Castell Nos. And Creggan built off a lot of really good work that was already happening at NRW. With Andy Hood was largely involved at the initial kind of site design there. And when we started looking at these sites, we looking at what human activities in the landscape had really affected the status of those sites in the recent past. So we're looking at what status they were currently in and how we might go about restoring them and return them to a near natural hydrological state, so raising that water table. And to do that, we needed to really understand the kind of background to what the pressures had been on in the recent past. And as Charles touched on, this landscape had probably been managed in a low intensity agriculture, extensive grazing regime on the uplands for a large period of time. So the industrial development, this is a 1945 area, I should say, sorry, of the project area. And the industrial development had really, vastly changed the base of these valleys, or in a fairly short period, had probably not affected the upland plateau anywhere near as much. So, I mean, the area is too wet for crops. They'd just been used as pasture land for a long period of time. Not to say that, there's probably some evidence of nitrogen and sulfur deposition from all the coal fires, chimneys in the valleys, and that probably did lead to some of the erosional features we see on some of our peatlands. So specifically Castell Nos, we've got some really large erosion channels on that site, and that's probably a result of that. But otherwise, these landscapes would have been wet and low intensity grazed for a long period of time. And this is just an image of the Mardy post. I'm sure some people will know that. This is intricately carved timber, dated as about 6,300 years before present. So it would have been around that kind of change from the late Mesolithic to Neolithic that Charles touched on. And really, all this is telling us is that humans are in this landscape and have been for a long period of time. And a lot of the peat development in this landscape occurred alongside humans using it, really. Now we're going to jump forward to 1967. So this is an aerial image from 1967 showing the project area again. And you can see not much has changed, although if you look down in the south of the project area and you're around the tops of the Avon Valley, you'll see that the plantation forestry is starting to creep in, and you've got resolving over here. And this change followed the Second World War, and where a lot of the landscape was set aside for new state conifer plantations, really. And this led to wide-scale drainage and ploughing and planting across the landscape. And then if we switch forward to a more recent image, this is around about 2018 and showing the outlines of the Penacamide Wind Farm and our habitat restoration areas again. And here you can see the landscape really is now, like Charles touched on, is conifer plantation dominated, essentially. Also, we've got a large number of wind farms in the landscape as well. When we think about the peat bodies that are present in the landscape and how those have changed with that land use, you're looking at drainage and ploughing to support tree growth, and also development to facilitate wind farm access. So just take a step back. Why did we start planting forestry and bogs in the uplands here? And really, it was driven by post-World War II acknowledgement that we didn't have much forestry anymore. We'd lost a lot of woodland to partly supporting the war effort. And this led to policies and interventions and grants, so government policy essentially to increase woodland cover. And this led to the wide-scale land purchase by the Forest Commission and the conversion to forestry from that previous low-intensity, extensive grazing land use. And some innovations in plough technology allowed it planting the deeper peats. And it was estimated around about 18,000 hectares of deep peat in Wales now is under forestry. And what are the implications of this? So how does this land use change that we've gone through over really a relatively short period? How does that affect how we might think about going into restoration of peatlands and thinking about how we create the hydrological conditions that allow them to form, so that kind of permanent wet status? You can think the effects are really the main aim of really the installation of the plough lines and the drainage is to lower that water table. So you can see this furrow in the middle here, and then the plough goes through and throws up a nice high dry ridge to plant your tree on, to give it a chance to get away, and this introduces a ridge and furrow microtopography. The concentrates flow away from the tree roots and off into a drainage network that extends it across and gets it off site as quick as possible, essentially. That's the aim. And that has a lot of knock-on effects on the mire vegetation that would have been present. It changes it, restrains where it is. You lose that kind of functional acrotelm in some areas of the peat, and you lose some erosional wastage through oxidation and erosion through water leaving the site quite quickly. And what does this look like? This is just a drone video of our Cwmsaibren restoration site, and you can see the linear lines moving away from you here are the plough lines from where it was ploughed. Lots of the crop on this site actually failed. So it's got just a scattered trees left. And these lines going this way, deeply incised ones, are the drainage channels that were installed to get water off that site really as quickly as possible and away down into the Nant Celsig. And that drawdown of the water table within the peat from the drainage and the ploughing and the increased evapotranspiration from the trees and the interception of the canopy as well would have reduced the amount of water getting to the bog surface. You get now a drying effect from all those multiple interacting factors. And that also changes the morphology of the peatland. So you've gone from this kind of less rough surface. There is a variable surface on a peatland, but it's a relatively low surface variation, into a much more varied surface with a more pronounced regular ridge and furrow topography. And that all feeds into the restoration and how we think about going about restoration. And also you lose your mire specialist kind of species. And you can see these drainage ditches can be quite deep and can also lead to lots of erosion. Not all of them, unfortunately, are filled with great bryophytes like Charles. Some of them are filled with lumps of peat as these get washed out and lost downstream towards the Severn Estuary. And you can see the oxidation on the peat on the side there as well. So how do we go about thinking about restoration at these sites when we know about the different pressures that humans have put on them through our actions of planting trees, ploughing, also historic erosional kind of activities? Well, peatland restoration is mostly focused on addressing those pressures to try and create more natural hydrological conditions and raise water tables within the peatland. So our restoration philosophy generally, and this is built off evidence coming out from various different areas, is to go in pretty early and pretty hard as we can, where we can, and undertake quite intensive restoration activities. And our framework really, this is kind of mine and Joey's thoughts put down into a schematic. It's really built off what you're dealing with on a site. So for instance, it depends whether you're on deep peat or shallow peat, whether there's stump present or plough lines present, how you go about undertaking restoration. So it really needs to be site specific. So if we take an example of our Craigan restoration site, so this is a restoration site sat above Glencorrwg, in between Glencorrwg and the Neath Valley. It sat along the upland ridge there, and we delivered about 48 hectares of restoration on this site in winter 2023. But baseline surveys of this site identified that it was mostly ploughed and drained and had an active crop on it up until fairly recently. So it had stumps in the ground. So it had those ploughs, it had those drains, and it had stumps. So that led us to identify ground smoothing as being the most appropriate kind of intervention for this site. That's going to remove that ridge and furrow microtopography. It also had no major erosion features on it, so we didn't need to think about blocking erosional features or doing any reprofiling works associated with those. And peat depth on this site ranged up to about 4 metres. And what does ground smoothing look like? I know lots of people have probably seen ground smoothing, but some of you might not have. And this is just a video of Pup, who's sat at the back, I think, doing some ground smoothing on the Craigan restoration site in 2023. And you can see the diggers lifting up these stumps, inverting them, pushing them into the ground at the back of the bucket, and then he's going to cross-track over those a couple of times to push them further in. And this is accompanied with using peat dams, taking scoops of peat and blocking that drainage network as well, where you come across drains. And that has a couple of different effects. It pushes down the surface of the peat. It removes that ridge and furrow microtopography, the regular microtopography that directs flows or directed hydrological flows, and creates a more chaotic, more semi-natural kind of microtopography. But we didn't only do ground smoothing. We also did some various other works, like conifer clearance. This is just a time lapse of some regen clearance, and also a Laurus sphagnum planting across those sites. And these are really supporting mechanisms that fast forward recovery off the back of any interventions, major interventions like ground smoothing. And what does it look like after ground smoothing? So this is Craigan, year 1 post-restoration. You can see a main drainage ditch here that's been blocked, holding water well. There's peat dams in here. And if you look across the rest of the surface, you can notice there's no stumps left, really. They've all been inverted and driven into the top of the peat. And vegetation is slowly coming back, but what it really is very wet at the surface. You know, we've been quite successful at raising that water table to near surface levels fairly quickly. But when we look at specifically our Castell Nos restoration site then, baseline surveys of this site identified it being slightly different from Craigan. This was a different baseline condition, needed slightly different approaches. So at Castell Nos, although it had been ploughed and drained for planting in the past, those trees had failed and burnt a couple of times as well. So there was no real standing timber on site in the areas we were looking at. And then when we were thinking about how we wanted to go about raising water tables there, we used a slightly different approach. So we used ditch blocking. Again, we were blocking all those drainage ditches off the site, but also blocking plough furrow lines with peat dams as well. So a high-intensity damming effort. And this was coupled with cross-tracking, where we just basically drive across the peatland in the digger in repeated methodology to try and push the surface down a little bit and collapse those upper oxidative layers. So you're having this combined effect of pushing the surface down closer to the water table as well as raising the water table through blocking the flow pathways off-site. We've delivered around about 30 hectares of peat damming and ditch blocking on this site, and that was done over 2022 and then again repeat works in 23-24. But this site, in baseline surveys of this site, also identified some really large erosional features, these things here. And they've been present, these are already present in the 1945 aerial. So these are probably an artifact of perhaps some of that industrial pollution causing erosion back into the peat faces. It's got some loss of vegetation potentially. I mean, we don't know, but that's maybe where they're from. And they would require a slightly different approach again. So they're really large features, maybe 3 or 4 meters wide. And for those, we installed a number of timber dams and timber and peat compound dams. And they've been fairly successful, although some of them have blown out in storm burnt. And this is just an aerial showing the north part of this site. And you can see these timber compound dams up the erosional feature here. This was a erosional feature about 3 or 4 meters wide coming right back up into the peat body. And you can also see our peat borrow pits. And these are the open water here and the peat dams in the plough lines. And these have acted together to raise that water table and bring it to the surface. And the reason those peat dams, those borrow pits have been left open was specifically to help support this species, water vole. So during baseline surveys of this site, we found a reasonably healthy population of water vole, although it was quite restricted at one point in site. And as part of the licensing around the works at Castell Nos, there was a commitment to basically increase as much as we could the amount of open water on site to help support water vole. And that's why all those borrow pits were left open. And Joey, I'm sure, will touch on what the effect of that been for water vole this afternoon. And then we come on to Cwm Cybran, which is our final HRA. Baseline surveys of that site identified it to be much similar to Castell Nos, so it's been ploughed, it's been drained, but crops failed. So again, you had that ridge and furrow microtopography and a drainage network, but no real stumps, so we couldn't really ground smoother as such. But we could do cross-tracking and ditch blocking like we did at Castell Nos. Unfortunately, baseline surveys of this site also identified that due to some concerns over slope stability above Blaen Cwm, that we really couldn't restore large areas of it, so we were restricted to working in this kind of 3-hectare site down in the bottom. But one of the benefits of that has now been that we have a no intervention control, a really good no intervention control across the other parts of the site that allows us to see how far we're moving away in our restoration areas from a degraded state, which is subsequently proved really, really useful. So this site we delivered around about 3 hectares of cross-tracking and ditch blocking in 2022. And that's what we've done essentially. And I should say, Bog Dog is really sorry you can't be here today. But yeah, I'm happy to take any questions.